We don't know when the geometry of the circle first attracted human interest, but we do know that this simple shape precipitated one of the most ancient and unresolved mathematical endeavors, the determination of pi. Pi is the ratio of the circumference of a circle to its diameter, a simple concept. Circumference is the distance around the outside of a circle, and the diameter is represented by a straight line that joins opposite sides of the circumference and passes through the center. The radius of a circle is the distance from the center to the circumference. Dividing the circumference of a circle by the diameter produces a value for pi. This ratio is the same for all circles. There are indirect references to this ratio in ancient literature, including the Bible. This quote refers to a circular brass pool constructed at Solomon's temple approximately 3,000 years ago. And he made a molten sea, 10 cubits from the one brim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it about. A cubit is an ancient unit of measurement, approximately 46 centimeters. This script tells us that this pool had a diameter of 10 cubits and a circumference of 30 cubits. Dividing circumference by diameter gives us a value for pi of 3. That is within 5% of currently accepted values. It turns out that determining a definitive value for pi is not so simple. Dividing circumference by diameter creates an unusual type of number, an irrational number. This is a decimal number that cannot be resolved. It never ends. The great minds of many civilizations have contributed to our understanding of pi. The ancient Egyptians appear to have understood this concept, and Archimedes developed a geometrical technique for determining pi. The value of this enigmatic constant continues to be refined. The value we all know is 3.1416, the value of pi to 4 decimal places. Currently, mathematicians have reduced pi to trillions of decimal places, with no end in sight. It is, after all, an irrational number. There are numerous ways to calculate pi. Here are 2. This method requires simply measuring the diameter and circumference of a circle. Use a circular can and trace a circle. To determine the circumference of the circle, wrap a string around the can and mark the overlap. Measure this length with a ruler. The diameter is the longest distance across the circle. Divide this value into the circumference, and you have an approximation for pi. This method is limited by the accuracy of our measurements. To get around this, mathematicians have developed some powerful tools and logical processes. They do not require measurements. This next method uses some of those tools. You'll need a basic knowledge of trigonometry, the geometry of triangles. I have some basic information about trigonometry at our website, hylaroad.com/pi. Again, we will start by estimating the circumference. This circle has a radius of r. Drawing 12 equally spaced radial lines produces this. Each center angle is equal to 30 degrees. Joining the points where the lines meet the circumference, we create 12 isosceles triangles. The length of the base of each triangle is equal to b. If we can determine the value of b, we can approximate the circumference of the circle by adding the 12 bases together. For this example, b equals 2 times r times the sine of 15 degrees. The circumference is 12 times that, which gives us a value of the circumference of 24 times r times sine of 15. The diameter of this circle is twice the radius, 2r. Pi equals circumference divided by diameter, which in this case gives us 12 times the sine of 15. The sine of 15 degrees is 0.2588. 12 times 0.2588 gives us a value of 3.1056 for pi. Not very close to the accepted value of 3.1416. The main reason, of course, is that our estimation of the circumference is not very refined. If we used more isosceles triangles, the sum of the bases would more closely approximate the circumference. This is what 24 triangles look like. The bases are moving closer to the circumference. Let's try 100 triangles. If you look back at our formula for 12 triangles, pi equals 12 sine 15, you will notice that 12 is the number of triangles and 15 degrees is 1/2 the angle at the apex of the triangle. If we use 100 triangles, each angle at the apex will be 1/100th of 360, 3.6 degrees. 1/2 of 3.6 degrees is 1.8 degrees. Pi then is equal to 100, the number of triangles, times the sine of 1.8 degrees. Using the calculator, we get a rounded value for pi of 3.1411, coming closer. I'll leave you to try 360 triangles. You'll be working with an angle of 1 degree. For those of you with advanced math skills, you will recognize that this solution is moving us towards the branch of mathematics called calculus. Currently, pi has been determined to trillions of digits. This quest reveals something about mathematics and something about human nature. This simple ratio continues to consume the time and resources of many members of our academic community. Visit our website, hylaroad.com/pi, for more information on this enigmatic ratio.